Hi Marina.
Hi.
It's very important always while working with beam shapers to pay attention to alignment. It is not dramatic, but it is necessary just to pay attention and provide proper positioning of beam shaper with respect to a laser. Okay, this is our demo setup for presentation, and here we can see the laser, beam expander, camera to catch the profile. So on a monitor we can see the profile of the laser that come after the beam expander. It can be seen here. So this is a green laser, so solid state laser, TM00 solid state laser. To mount the beam shaper properly with respect to the laser, we will use 4-axis mount, so X, Y and tilts, with all buttons. We will work with these beam shapers. So here you see the so-called F-piShaper and Focal-piShaper, so different devices. But the procedure to align the beam shaper is very similar, and I will show how to do this. Before installing the beam shaper, we will use a simple device that we call this aligner. This practically is a tube with the thread that is the same like a beam shapers, compatible with the mount, and two holes precisely machined, so we can first align the aligner, be sure that it is an optical axis with the laser, and then we will install the beam shaper. So there are two ends, so the 2mm aperture on one end and another aperture at the output, and output has 3, 2 and 1 mm diameters. In the beginning, where we take only first aperture, input aperture, output is empty, and we see the profile on the monitor, and we have to put the crosshair to the center of a spot because we will use it later. And when we install the aligner, you see the picture changes. We have 2mm aperture, and we have a diffraction pattern in as a set of rings, diffraction rings. And what we have to do now, just to align the aligner, we have to, by using X and Y alignment, bring the spot to the crosshair. So the center of this diffraction pattern should be centered with the crosshair that we installed before. So you see the picture is now symmetric, and we are now sure that this input aperture is an optical axis. Then, to check how it looks like in angular, we will use a second aperture. First we will take 3mm aperture, and you see how the picture changes again because of misalignment, angular misalignment. So we have 2mm aperture at the entrance and 3mm aperture at the output. This means the beam should pass through the output aperture without any truncation. And when we use output aperture, we always have to use only angular alignment, no X and Y, only tilts. And the main idea is just to get again a symmetric round picture, no any distortion to picture. Then we take 2mm aperture. So you see we still have to improve a little bit in vertical direction and a little bit horizontally. Here's one feature. When we use angular alignment, the rotation of the mount is around the center that coincides with the aperture, input aperture. This means that when we use angular tilt, we do not change the position of first aperture, input aperture. The last aperture is 1 millimeter, so you see it's almost aligned. We have only improved it a little bit, yeah, and you see very nice symmetric picture. Now we are sure that both apertures are on the optical axis, and this means also that mount is aligned with respect to the laser. In the beginning, we will work with a F-piShaper, so device that converting collimated Gaussian beam, single mode or multi-mode, to collimated flat top. We have collimated Gaussian beam. We pre-aligned the mount, so when we install the F-piShaper, we can expect more or less good picture. You see the profile we have now. It is not completely perfect, yeah, but it can be a little bit improved, yeah, by some additional alignment. So what is important to see? For example, we see in horizontal direction, we see maximum on right side and minimum on left. So this is a typical sign for angular misalignment, and we have to improve it by angular tilt. So after aligner, we have still to use the alignment means on the mount to tune the position of the F-piShaper. Now you see the profile is flat top in both directions, so horizontally and vertically, and this can be considered as a final profile after the alignment of F-piShaper. So you see the F-piShaper is aligned now.
So Alex, what's with the rim?
You mean the rim that is around the spot? Yeah, I have to explain a little bit. This laser that we use is just a green pointer. So this is a TM00 laser, but it is not perfect laser like we can get in, let's say, high quality lasers. If we look on the input profile, you see there are some extended tails, yeah. And basic idea of F-piShaper operation is that when we have a Gaussian beam at the entrance, we spread energy from the center and collect it from periphery. And this means that if we have too much energy in wings, yeah, we just collect it, and they appear on in the final result as a bright rim. But with good lasers, it is possible to get much better results. So it really depends on the laser. But now we are speaking about alignment, and for alignment itself, it is even easier to align with rim, but of course it is necessary to avoid this in real life. This is another device. It converts. It's intended to create flat top spots in back focal plane of a lens installed after it. Yeah. So this is a Focal-piShaper. Since we already made the alignment, we can simply install it in our system. Yeah. And now we can see that there is another view of a pattern after the F-piShaper. The feature is that if we want to get flat top spot in the focal plane, at the output of F-piShaper we have to provide so-called airy disk distribution that is specified by central spot and some rings around. This is what we see on our monitor, the central spot and some rings that are introduced at F-piShaper. And on this stage we have to correct the position of F-piShaper because the pattern, again, like always, should be symmetric. It means that we have to make it this set of rings should be centered with respect to the central spot. Yeah? And when we take the profile right after the beam shaper, we can use again only X and Y alignment. So only X and Y, no tilts, because tilts will be corrected and will be checked and corrected when we will work in the focal plane of a lens. So this is a typical pattern after the Focal-piShaper, and it is considered okay because we have rings centered with respect to the central spot. Now we have to check what happens at the focal plane of a lens. So, by the way, you see the profile, how it changes. So the spot is pretty round, and at a longer distance it looks like airy disc. So now we will use another rail and put the camera at a longer distance. So we see what happens. So at a longer distance we still have symmetric pattern, yeah. And now since we have to realize now a focus spot, yeah, we will use 1 meter lens for alignment purpose. Of course, in real life, in real equipment, in real applications, people use different lenses with shorter focal lengths, 100, 200 or several millimeters. It depends on application, but for alignment purpose it is very convenient to use 1 meter lens because the final spot will be several hundreds microns size, and it is possible to use the same camera like this, camera based beam profiler, to check the profiles before the beam shaper, after beam shaper, and in focal plane of this lens. And now you see the beam is focused. And we will put a camera at a distance about 1 meter where the focal plane is located. And we can see now on a screen the spot, and now I have to say some words about the design of beam shaper itself. Yeah? So the beam shaper has so-called focusing ring, and when we rotate this ring we can move the focus across the camera, yeah, and analyze profiles at a particular distance, yeah, by simple rotation of ring. We can of course move the camera, or we can move a lens, yeah, and we will see how profile changes, because in case of airy disc we always have variable profiles, and we are speaking about optimum profiles happening by focusing of a beam. We still did not finalize alignment. To finalize it, we always recommend to get so-called do not spot. So you see this, it looks round, yeah, but it is not perfect, yeah, because the maximum intensity is in the bottom of a beam, yeah. And now we have to correct this profile, get it provide it again round and symmetric using angular alignment. So this means that we have to improve position of these buttons. And a simple rule can be formulated as by using this button we have to move the spot in direction of maximum. So in this case we have to go down. We use a button for vertical direction. So you see what happens, the beam becomes more round and more let's say symmetric. And now we have to go right, horizontally. So we move horizontally. Of course we have magnified beam and a little bit more down. Yeah. So this profile can be considered as a practically very close to optimum for this laser. We can consider that the alignment of beam shaper is finalized, and now if we rotate the focusing ring, we can get different profiles and in real life choose optimum one for operation in a particular application. We can do the same by moving the camera or material in application, or if it is a machine and we have possibility to change position of a lens, we can move a lens. For alignment, that's it. When we get this symmetric pattern, we can consider alignment is finished. Now we have to take the lens off. We have to put a real lens in a system, and we will get in the focal plane of that new or that normal lens the same profiles like we saw now on the camera. So that's it for beam shaper. For Focal-piShaper it's enough, and we can work in a real system. Would you like to try?
Really? I'd love to.
Yeah, why not? Yeah, you see, it's not so difficult. You can try. I make some misalignment, and you will see how to work with this yourself.
I would say at first I put the crosshair in the middle of the beam.
Okay,
Like
yeah,
that.
that's right. Yeah.
Next, I wanna take the aligner,
Okay.
which we have here, which already has the 2mm aperture at the entrance, and I will put it into the mount, and it has right now no aperture at the
Okay. So
Exit.
no aperture at the output.
That's right.
Okay. Yeah, we can try.
We see that the pattern is showing us it's not quite aligned yet, so I will do a vertical and horizontal alignment here.
Yeah. Okay. And with only X and Y, yes. Only X and Y translation has sense here. Yeah, right. And horizontal.
Okay.
Okay, perfect.
Here
So-
we go. Now it's aligned. Now
Yeah.
I take the 3mm aperture,
Yeah.
put it onto the exit,
Okay.
and I see. Ooh, we do have some misalignment. So
Yes,
I have to do the tilt.
Yes, it's necessary to make a tilt, and you see very strong misalignment in horizontal, so it's necessary to use this button.
Okay.
Yes, right. Absolutely right. Yes. Perfect.
So now I better try to
More.
even more.
Yeah, even more. Yeah.
Okay. Oh yeah, sure. I mean, hello.
Yes. You see,
Yeah,
it is looks like opening. Yeah.
yeah.
Okay. Yeah.
Wow.
Yeah.
More?
Yeah, I think enough. Yeah.
Enough now.
No, because all the rest we will do this with the other apertures. Yeah.
Okay, nothing here, right? Nothing in the
Nothing to
vertical
do.
tilt.
Nothing to do vertically, but we have.
Okay.
Okay. Now.
Now I take the 2mm
2
aperture
millimeters,
at the exit.
right? Yeah. Step by step. 3, 2, and later we'll do 1. So
Okay.
now you see we have to improve it in vertical direction. Yeah.
Mhm.
Again, angular alignment, so only knobs for tilts. Yeah,
Mhm.
right. Okay. And it's too much
No.
already. Yeah, come back. Okay. And now,
And wait, hear anything? No, right? It's pretty much good.
yeah,
All right, now use the 1mm aperture.
it's 1 millimeter. Yeah. Okay.
Almost there. I
Yes.
use again the angular.
Yeah, right. Okay, perfect. Perfect. It's enough. It's
Okay.
already enough. Yeah.
So now
Now we can put the beam
Perfectly
shape.
aligned.
Yes.
you can take it off, and if you would pass me the
Yeah, the
pi-shaper,
pi-shaper.
please.
Yeah, pi-shaper.
Mhm.
Do you remember it converts Gaussian beam to
Collimated flat top.
perfect. Yeah. So collimated Gaussian to collimated flat top.
Now I see an almost perfect profile, but I do have to make slight adjustments.
I would recommend to align horizontally angle, because you see there is a difference in the right and left side. So horizontal angle is
so
again,
this is here?
yes, exactly, yes.
Ah, yeah, because I want to get these here.
Yes, yes, yes. We have to get the same height, yeah, one
Alright.
direction, yeah. Yes, yes. So
That's good.
basically, you see, it is
Great.
flat top profile horizontally and vertically. This is an aim of alignment. That's it.
That's
Because,
it, right?
For alignment, that's it. There are some imperfections here that you can see that vertical profile is flat, horizontal is a little bit convex, but this happens because we have elliptic input beam.
Right.
So for alignment, that's it. And as you see, it takes a few minutes, and the beam shaper is aligned.
It's so great.
Yeah, really.
Thank you so much.
Okay, thank you.